Welcome to all my Psychology of the Human Lifespan students. Um, Having some connectivity problems earlier today, so I'm taking today's lecture and putting it onto Linden 4 YouTube, and I will be sending you links to that a little bit later. And just to kind of orient where we are, you should all have your exams grades back by this point. The grades overall were really good. And on the first exam, you have a chance to raise your grade if you wish to. So read my comments on the emails that I sent to you. I'm still waiting on a couple of them. So let me just say to you that if you haven't turned one in yet, you still do have an opportunity to do that. And today, what we're going to be talking about is basically the material in Chapter 6 of your textbook. Chapter 6 focuses on two main areas. The first one is the last two stages of Piaget's theory of cognitive development. And these two stages, called concrete operations and formal operations, are the stages that correspond with children from around the age of 7 through 11, and then from 11 on into adulthood. So you already know some things about Piaget from a couple of weeks ago. We talked about assimilation and accommodation. We talked about the first two stages. Many of you answered those questions on exam 1. And just to remind you, I'd like to ask you to go back and make sure you're familiar with this. But the first stage in Piaget's theory, from birth to about 2, give or take, is the sensory motor stage. And just to review for you, the establishment of body boundaries, the establishment of what are called feedback loops, object permanence, and the very beginnings of language development toward the second half of sensory motor. The second stage that we also already discussed is called the pre-operational stage, and that runs from the age of 2 all the way through the age of 7. 5 years, so there's a lot of development that happens cognitively in 5 years of a child's life. Again, to remind you, the first part of pre-operational is characterized by, in a sense, what children can't do. So their language skills are developing tremendously. That's a good thing. But their thinking is also egocentric. We talked about egocentrism. We talked about animism, the belief that inanimate objects are alive. We talked about how very young children in the pre-operational stage have trouble solving problems because sometimes they fixate too much on one part of the problem and can't see the big picture around it. We also talked about, and this is discussed in the book, what's called the mountain problem. Children in the pre-operational stage, because they're egocentric, cannot shift and see another person's point of view. They can't imagine what a mountain range would look like from the other side, looking at it from the other direction. But then the other thing that's important is toward the end of the pre-operational stage, 5, 6, 7, a child's thinking gradually becomes less egocentric. So you can see that even though they're still in the second stage of cognitive development, they're getting close to making a jump around the age of 7 to the third stage. So everything right up to this moment has been a review, but here comes some new information. I want to remind you again, all of this is discussed at length in Chapter 6 in your textbook. So the purpose of this lecture is not to substitute for you reading the book and digging into the material. So according to Piaget, somewhere around the age of 7, a child gradually moves into the third stage of cognitive development. And this stage is called concrete operations. Concrete operations. He argued that it lasts from about 7 to 11. And then, as we're going to see in a few minutes, around the age of 11, if things go well and the child makes it to stage 4, they will move from concrete operations to the fourth final stage of cognitive development called formal operational thought. This is the beginning of true adult thinking ability. Now, one of the things I want to mention at the outset is Piaget's ages attached to each stage turn out in modern day America to be incorrect. In America today, children do move through these four stages in the order in which Piaget discovered, but they tend to do so at an earlier age. Remember that a lot of Piaget's research was mid 20th century and studying cognitive development of children in Switzerland. So now we're looking years later in the United States, and in the United States, kids move through these stages more rapidly. So the ages for concrete, so for sensory or pre-operational, right, 2 to 7, many children before the age of 7 in America have already moved into the third stage called concrete operations. To Piaget, it's 7 to 11, but in America, it starts earlier and it tends to end earlier as well. So that's one of the ways in which Piaget's theory was not correct, at least for currently in the United States. Concrete operations. All right, so let's take those two terms. Operations means this is the beginning of a child's ability to think logically. The concrete operational stage is the first time in a child's life that they can begin to think using logic. But the logic is limited. They don't have the ability to think abstractly. They don't have the ability to think about complex things that are intangible, like abstract ideas, but they can begin to think logically. And the word operations refers to the ability to think logically. Now, why is this happening? Well, it's happening because this child's brain is maturing genetically, and they're having these new challenging experiences with their environments, right? And so remember assimilation and accommodation. Sometimes a child's way of thinking no longer works. That's called disequilibration. We talked about that. And that forces a child to move to a higher level of development, right? And so concrete operations starts off with a child who is a lot less egocentric at 7 than they were at 5. In those 2 years of living, a child becomes more able to shift perspective. They become better able in concrete operations to recognize the difference between appearance and reality. They're not so easily fooled. Now, they can begin to solve problems by using logic. To solve a problem logically means to apply a set of rules, a set of strategies to attempt to solve some sort of problem. And that's true whether it's a math problem or a word problem or a personal problem or figuring out what's right or wrong. You know, problems come in all different shapes and sizes. This is the first time in a child's life they can begin to use logical rules to solve problems. But remember what the name of this stage is: concrete operations. So what do we mean by concrete? The word concrete means that their ability to think logically is still limited and will remain limited until they move to stage 4 around the age of 11, according to Piaget. Now, by limited, I mean concrete thinking. When we think concretely, we are still tied to our senses. So let me give you an example of that. Consider the following problem. In what way or in what ways are an orange and a grapefruit alike? In what ways are an orange and a grapefruit similar? There's a lot of answers that are correct to that question. Some of those answers are correct, but they're concrete, while other answers are also correct, but they reflect a higher stage of thinking called abstract thinking, which is what formal operations is, which starts around the age of 11, right? So let's consider a few possibilities. If your answer is tied to your senses, if you picture an orange and a grapefruit, and you say they both smell the same or they both have a similar smell, That's a correct answer, but it's also a limited answer because it is concrete. It is tied to something tangible, information coming in through your nose. If you say that they are both round, that is also correct, but that is also a concrete answer because the shape is something you can see with your eyes. If you say they both have a similar taste, that is also correct, but that is also a concrete, limited, logical answer because it involves taste. Now, let's say that another correct answer you come up with is they're both fruit. That's different. Fruit is a categorization. It's a taxonomy, right? To count both as fruit is to be able to answer that question, not concretely, but abstractly, to be able to put them into a similar category based upon an abstract idea. Fruit is a concept, right? Taste is a sense. To say that they're both citrus fruits is an even a bit higher level of an abstract idea. Are there many different types of fruits other than oranges and grapefruit that are not citrus fruits, right? So the ability to think abstractly is a higher level thinking ability, okay? Children in concrete operations can think logically and solve problems in a brand new way, but their thinking tends to be limited to things that they can directly experience through sensory data, through sensory input. If they make it to the fourth stage, right, to formal operations, that opens the door to a whole new way of thinking, and we will talk about that in just a couple of minutes. Now, I'm just looking at my cheat sheet here to make sure I'm getting through everything that I want to. Okay. So one of the very important things that happens during this third stage of concrete operations is somewhere in this stage, usually earlier age-wise, a child will master something that Piaget called the principle of conservation, the word conservation. And this is a game changer in a child's cognitive development. Once they've mastered conservation, they understand the world in a brand new way. And for you and I to function as adults, we have to be able to do this. Adults who have cognitive deficits where they never master this principle will not be able to function in an adult way cognitively in the world. So what is the principle of conservation? There's a lot of ways to articulate it. Let me give you one of many. It is the understanding that the appearance of an object may change, but its underlying qualities remain the same. Appearance of something may change, but the underlying properties or qualities of that something remain the same. Now, there are many ways that Piaget demonstrated the principle of conservation. But before we get to those, let's just think of kind of a real life example. When a child has mastered the principle of conservation, they recognize that while somebody's physical appearance, like the way their mom or dad looks, could change as a result of aging or as a result of cutting off your beard or growing a beard or as a result of being injured, in an accident that changes the way you look physically, that even though the appearance looks different, it is still the same underlying properties of that person that makes them them. Once you've mastered conservation, you live in a world that is more cognitively stable. You become better able at separating appearance from reality. Now, if we think back a few weeks, one of the reasons we need to protect young children pre-conservation is to a young child, since they can't distinguish the way something looks from the way it really is it very easy for young children to be fooled. If you appear to be a nice person, they assume that you are. Once we've mastered conservation, we can think more deeply into a topic, and we are not so easily misled by the way something appears to be. So we recognize, and it's like a loss of innocence, we recognize that while somebody might appear to be a certain way in the way they act toward you, that doesn't necessarily mean that deep down that's who they really are. This is a loss of innocence, but it's an important part of cognitive development. Can you imagine if all adults couldn't do this? If we weren't able to conserve, we would be incredibly easily fooled. And one could argue that even for those of us who have mastered conservation, it's still easy for us to get fooled. Sometimes our brains look at the appearance of the way somebody acts in a certain setting and assumes that that's who they really are. But anyway, so let me give you an example. One way of demonstrate that Piaget demonstrated the principle of conservation is with putty, right? Or with clay. And if you take a fixed amount of clay, like a ball of clay, right? And you have the child watching you and you compress that into a ball and it's a certain size. And then you take the clay and you smush it out into like a long, like snake-like object. And you say to the child, is there more clay when it's like this or at like this, or is it the same? A pre-conservation child will almost always tell you that there's more clay when it's stretched out like this. A post-conservation child will look at you like you're a fool and say, what are you talking about? It's the same amount of clay no matter which way we shape it out to be, right? Now, you can also demonstrate that with liquids. If you take a certain amount of water in a beaker, a certain quantity of water, and then you, with the child watching, you pour all of that water into a second beaker, which is very narrow but very tall. And then you take all that water and pour it into a third beaker that's very shallow and flat. And you say to the child, is there more water in the second beaker, the skinny, tall one, or the third beaker, the flat, wide one? A pre-conservation child, being fooled by appearance, will tell you that there's more water in the second beaker because it goes all the way up to the top and it looks that way. A post-conservation child will immediately look at you and say, it's exactly the same amount of water, no matter how it appears, because you started with the same amount of water. So now to you and me as adults, this may not sound like a game changer. It may not sound like a big deal. It's an enormously big deal. I worked with adults in various settings who were in their 30s, 40s, 50s, or 60s, but cognitively their development had stopped around the age of 6 or 7. And even though they were fully, age-wise adults, cognitively, they had never mastered the principle of conservation. Are these people who will have a tremendously difficult time doing certain sorts of things, learning certain sorts of things? Do they remain psychologically and emotionally vulnerable because it's so easy to fool them? So it is a very important thing. Now, somewhere around the age of 11, and again, remember the problem with Piaget, it happens earlier for American kids. Many, but not all people, will move to the fourth stage. And this stage is called formal operational thinking. In Piaget's theory, this is the final stage of cognitive development. If we make it to stage 4 fully, we will, barring brain damage or dementia later in life, we will remain in stage 4 the rest of our lives. So in Piaget's theory, formal operational thought is the highest level of cognitive development. Now, people who have come along after Piaget, some people argue that there's a 5th stage that may kick in for a smaller group of adults somewhere later in adolescence. And for those who believe in that, it's called post-formal operational thought, and it reflects a very high level of abstract thinking ability, the kind of abstract thinking ability that's necessary to do very high level math and physics and certain sorts of sciences. But let's talk about formal operational thought. So we know what the word operations means, the ability to think logically using different sets of rules to solve different kinds of problems. Formal means abstract thinking. The ability to think abstractly is the ability to use abstract logic to solve problems in life. So let's take the word love. If you say to a concrete operational child, what is love? They will talk about love in terms of a feeling that they can feel inside of them, that they can connect with certain people in their lives that they have that feeling towards. When you ask a formal operational thinker, let's say in a philosophy course, what love is, they will attempt to struggle with that concept abstractly, to define it in abstract terms, in ways that are not necessarily tangible. You could take that same concept and apply it to a word like truth or honesty or justice. Right? Abstract thinking is the ability to solve problems in part by doing what is called hypothesis testing. And I bet when you hear that term, it sounds like scientific method, right? When you can think abstractly, you can sit in a chair and not have to get up physically, but just sit there, define the problem in your brain, and then generate a number of different hypothetical solutions to that problem, and then trace where each of those solutions will lead. And by doing that, you can eliminate false solutions and sometimes narrow down the workable solutions. We can create a hypothesis in our mind to solve a problem and then generate and test cognitively different solutions to that problem. Now, this is hard stuff, right? But if you think about math, think about higher level math, right? Think about calculus. Are there ideas in higher level math that don't have easily translated tangible realities? Or in physics, right? Think of different theories that attempt to explain what's going on at a micro level of subatomic particles, right? These are abstract possibilities. They are deeply embedded in abstract math. It takes a brain that can think in highly abstract ways to be able to attempt to solve those problems. Right? But let me say this. Two people could both be in formal operational abstract thinking, but one person could have a higher level ability to think abstractly than another. Or one person might be able to think abstractly in a high level way when it comes to mathematics, but not so much when it comes to words, verbal IQ, using words as abstract tools, right? Now, if you think about somebody like an Albert Einstein or Stephen Hawking, right? Their level of abstract thinking was one in many millions. Most of us can't go there in the same way that they could. I can certainly think abstractly in fairly sophisticated ways, but I don't have the tools to think with the same level of abstraction around certain concepts that they did. You know, life ain't fair. But on the flip side, if you could not think abstractly at all, if you were in stage 3 and not in stage 4, no matter how hard you work, you can't graduate from college. You can't do it. You don't have the cognitive tools, right? Are there many college courses that require the ability to think in abstract ways and solve abstract problems? Indeed, right? If all college courses were nothing more than memorization, lots of children could easily get through college. But to solve problems abstractly, whether they're word problems, verbal problems, math problems, philosophical problems, right, requires the ability to be well into stage 4. So I guess what I'm saying to you is that if you're in my class and you're thriving as a college student, you are capable of formal operational thought. Though it doesn't sound fair, are there a lot of jobs and careers which require a very well-developed ability to think abstractly? And the answer is yes. Right? To do engineering, you have to be a highly abstract thinker. To to do certain types of writing, you have to be highly abstract in your thinking. Right? Um, Now, I don't mean this to sound elitist. I'm just saying that's how it works, right? But could somebody spend their whole life pushing a broom as a job and still be capable of ultra high levels of abstract thinking? Of course. It may not be reflected in the work that they do, but then that cognitive fourth stage ability could still be very much in their brain. And that's the story for a lot of people, right? But the reverse is different. Right? To get through graduate school in pretty much any discipline area, you must be capable of high levels of abstract thinking. You can't do it otherwise. It's just not in the cards. Okay. So we've got 4 stages. Now, other people have come along post Piaget and added that 5th stage that for some people kicks in mid to late adolescence, called post-formal operational thought. And this is an ultra high level of abstract thinking. But let's stay with these 4 for the purpose of this for this course, and what's important to us. Now, it's important also in the book in chapter 6, notice the name Vygotsky, Vygotsky. Vygotsky is a cognitive psychologist who came along after Piaget and refined and tweaked some of Piaget's work. And I already mentioned to you one of the things that Vygotsky discovered, which is that in America, children move through these 4 stages, but more rapidly. But the second thing that Vygotsky realized is that one of the mistakes that Piaget made was his model, Piaget's model is an interactional model, right? Genetics interacting with environment. And that is certainly true, right? We're born with a brain that is genetically programmed to grow cognitively. But what Piaget did not pay enough attention to was the role of society and culture in shaping cognitive development. And there is a significant influence that society and culture has on the way we develop cognitively. Most of the research on Piaget's theory has looked at children cognitively developing in Western cultures, Western Europe, North America, and so on. This map of cognitive development may look quite different for children growing up in non-Western societies, where the environmental forces could shape a child's cognitive development in a number of different ways. So when you read about this theory, these 2 stages in chapter 6, notice how Vygotsky, in a sense, critiqued Piaget's theory. Piaget certainly got some things correct. He didn't get everything correct. Then realistically, if you're the first person to really study something, how are you going to get everything correct? That's not a realistic expectation anyway. Now, there's a second half to chapter 6, and it focuses on intelligence and IQ testing. And I think what I'm going to do is, we're almost at 30 minutes now. I'm going to shut this down in just a minute, and we're going to take a quick look at intelligence and IQ testing at our next Zoom class next Tuesday. So you should have your grades on exam 1. I was pleased with the way things worked for most of you. If you've got any questions, anything you need clarification on, rlinden@sussex.edu. And I will, so it's about 8:15 on Tuesday night, and I'm going to get this put up on YouTube, and reach out to me if anything I can do for you. Take care.